I've already told you the symmetry operations present in a molecule, they form a group. Again, a group is a set of entities which satisfy the following conditions. First one, it should have the closure rule. Second one, the set should have its own inverse element. And the third one, it should have the identity element which commutes with all the elements of the group. Fourth one, the function should be associative. If all the elements of the group commute, then the group is called an abelian group. If all the members of the group are generated from one of the members of the group, then it is called a cyclic group. In order to know whether a set of entities form a group, we constructed multiplication table. I have already clearly explained to you how the symmetry operations are present in the water molecule form a group using the multiplication table. Today, we are going to construct the multiplication table for the symmetry operations present in the ammonia molecule. Today, we are going to construct the multiplication table for the symmetry operations present in the ammonia molecule. I have already told you the model for ammonia molecule. This is the structure of ammonia molecule. It is pyramidal in shape, and this is the nitrogen. This is NH bond, NH bond, and NH bond. The symmetry operations present in the ammonia molecule are first the identity element E, and then the C3 axis which passes through the nitrogen. Because for the rotation of 120 degree, you are getting identical configuration. Therefore, there exists a C3 axis. C3 axis is the symmetry element, but the symmetry operation is C3 once, that means rotation for 120 degree, C3 twice, that is the rotation for 240 degree, C3 thrice becomes E. When you rotate the molecule for 360 degree, you are getting the identity element. Therefore, the C3 axis has two operations, C3 once and C3 twice. Similarly, you can assume a reflection plane here. The reflection plane which passes through the nitrogen and the NH bond will reflect this hydrogen over here and this hydrogen over here. Therefore, this is a sigma V because the principal axis C3 is present in this plane. Therefore, this is sigma V. I can use a small scale to explain this. And this is sigma V, sigma V. Similarly, another sigma V along another NH bond and another sigma V along another NH bond. Therefore, I can mention these three sigma V's as a sigma V prime or sigma V double prime and a sigma V triple prime, or sigma V dash, sigma V double dash, or sigma V triple dash. Therefore, totally we have 6 symmetry operations: E, C3 once, C3 twice, sigma V dash, sigma V double dash, and sigma V triple dash. Therefore, we are going to construct a multiplication table which will contain 6 or 7 columns and 7 rows. Therefore, this is a big multiplication table. And in order to do the multiplication table, I am going to look at the ammonia molecule from above, like this. Look here, something like boron trifluoride. Because this presentation has no role in constructing the multiplication table. Therefore, I am going to look at the molecule from above, like this. You are going to view like this. Let me say this is H1, H2, and H3. And assume that plane which passes through H1 is a sigma V dash. That plane which passes through H2 is a sigma V double dash. That plane which passes through sigma V triple dash, H3 is a sigma V triple dash. Now, suppose I rotate the molecule for an angle of 120 degree, automatically the H1, H2, H3 positions will change. But you should not change the sigma V double dash, sigma V triple dash. Sir, I have rotated the molecule, sir. Therefore, I am, suppose, watch closely this model. Let me say, this is H1. Therefore, this is sigma V dash. Suppose I am rotating the molecule and then reflecting. I am rotating like this. Now, this place is occupied by H2. Don't say this is sigma V double dash. Again, it is sigma V dash. Because sigma V dash, sigma V double dash, sigma V triple dash, that depends upon the position, not upon the hydrogen number. See, when I present the table which I have constructed, you will understand. Every step I am going to explain. Every step and each and every movement I am going to explain. Therefore, if you look at the table, then you will easily understand. And also, when you are rotating the molecule, you should rotate in only one direction. You choose your own direction, that doesn't matter. But if you start in anti-clockwise direction, you continue to rotate in anti-clockwise direction. You do not change the direction in between. Similarly, if you start in clockwise direction, you continue to do in the clockwise direction. Therefore, I'm going to construct the multiplication table. You look at these pictures. So this is the multiplication table. Look here. Now look. This is the ammonia molecule. This is how we usually represent. Actually, this arrow I have put here just to make you understand that you are looking at the molecule from above. So that the molecule will now appear like this. So nitrogen is at the center. You are looking from above. This is hydrogen 1, hydrogen 2, hydrogen 3. So rotation is in the clockwise direction. The reflection plane which passes through hydrogen 1 is sigma V dash. The reflection plane which passes through hydrogen 2 is a sigma V double dash. The reflection plane which passes through hydrogen 3 is a sigma V triple dash. I have already told you, even if you rotate the molecule, the positions of hydrogen 1, hydrogen 2, hydrogen 3 will change. But the positions of reflection planes will not change. Now this is the multiplication table. E, C3 once, C3 twice, sigma V once, sigma V dash, sigma V double dash, sigma V triple dash. Similarly, in the column side, E, C3 once, C3 twice, sigma V dash, sigma V double dash, sigma V triple dash. As usual, the first row and the first column can be easily filled because you are going to multiply by the identity element E. When an element is multiplied by the identity element, it won't change the element. Therefore, as such, you can simply write E, C3 once, C3 twice, sigma V dash, sigma V double dash, and sigma V triple dash. And also the first column also you are going to multiply by E. Therefore, the elements can be written as such: E sigma C3 once, C3 twice, sigma V dash, sigma V double dash, sigma V triple dash. Now the other portion of the table has to be carefully filled in. Now look, the first one, C3 once and C3 once will result in C3 twice. I am rotating the molecule for 120-degree, column operation first, row operation second, C3 twice. Actually, there is no strict rule to do the column operation first or row operation first, but anything which you start in the same manner, you have to continue. Therefore, we have made our own rule that the column operation has to be performed first and then the row operation. Now look here. When you do C3 twice, C3 twice means 240-degree followed by C3 once, another 120-degree. Therefore, as a whole, you might have rotated 360-degree. Therefore, it is identity element E. First, let us finish off the places where we get the identity element. Look here, C3 once, 120-degree, C3 twice, 240-degree. Therefore, you are getting identity element here. And in the third one, you look, sigma V dash, again sigma V dash. You are reflecting and again reflecting in the same plane, you are getting E. Similarly, sigma V double dash, sigma V double dash, you are reflecting and re-reflecting about the same reflection plane, you are getting E. Similarly, sigma V triple dash and sigma V triple dash, you are getting E. Now, the first complicated operation begins here. Sigma V dash and C3 once. What will be the resultant? What will be the combined operation for sigma V dash and C3 once? Look here. Look at this molecule. First, this is the first configuration we have taken. I operate sigma V first. When I operate the sigma V first, what happens? I assume a plane which passes through the NH1. Therefore, 3 and 2 positions are interchanged. So this is the result of the first operation. And then I am rotating the molecule for 120-degree by C3 axis once. What happened? The H1 will go there, H2 comes here, H3 goes here. So this is the result of the second operation. Therefore, what will be that one single operation which will make this configuration into this configuration? Look at carefully. The hydrogen 2 remains in its own place, whereas 1 and 3 are interchanged. Therefore, a reflection plane which passes through the 2 position will be the operation which will make this change. Therefore, the combination of sigma V once and C3 once will result in sigma V double dash. Are you able to understand? So look at the next combination, sigma V double dash and C3 once. What is sigma V double dash? That plane which passes through N hydrogen designated 2. Therefore, if you assume a plane here, the 2 hydrogen designated 2 will remain its own place and 1 and 3 will be interchanged. See, 3 comes here, 1 goes there. Now, the next operation C3 once is performed in the clockwise direction. Therefore, it is rotated. 1 comes here, 2 goes there, 3 goes here. Now, from this configuration to this configuration, what is that single operation can be made? So 3 remains in the same position, 1 and 2 are interchanged. Therefore, if you perform the sigma v triple dash operation here, that will result in this configuration. Therefore, the combination of sigma v double dash and the C3 ones will result in sigma v triple dash. Now, the next operation, sigma v triple dash into C3 ones. Look here, what is sigma v triple dash? It is reflecting about the plane which passes through NH with the designation 3. Therefore, NH3 remains here. 1 and 2 are interchanged. And then I am rotating the molecule for about 120 degree. Therefore, the 2 comes over here, 3 here, and 1 here. Now you find out that one single operation by which you can attain this configuration from this configuration. You look here, H1, H1 remain in their own position, 2 and 3 are interchanged. Therefore, any reflection about the plane which passes through NH1 will result in this configuration. Therefore, it is sigma V1, V dash. Therefore, the combined operation sigma V triple dash and C3 ones will result in sigma V dash. As usual, C3 twice and C3 ones will result in E. And also C3 twice and C3 twice, what will happen? Can be written as C3 thrice and C3 ones, which is equal to C3 thrice is E, C3 ones, E into C3 ones will be C3 ones. So this is how the first column is completed. Now look at the first product. Look here. Is it clear? C3 ones, C3 twice, C3 twice, and C3 ones E. And look here, C3 and sigma V double dash, sigma V triple dash, and sigma V dash. Similarly for C3 2 into E, C3 2, C3 twice, C3 twice into C3 once is E, C3 twice into C3 twice will result in C3 once because C3 3 into C3 1, where C3 3 is E. E into C3 once, it results in C3 1. Now look the other operation. Look here. Look here. Sigma V1, C3 twice. What is sigma 3 1? It is the reflection about the plane which passes through NH1. So, as a result, you get hydrogen 1 remain in its own place. 2 and 3 are interchanged because of the reflection. Now I am operating the second operation, C3 twice. C3 twice means 240 degree rotation. Therefore, the 1 will move to the position of 3. Look here. 2 will move to the position of 1. Look here. 3 will move to the position of 2. So this is the result of 2 operations. Now you identify that one single operation which will result in the conversion of this configuration into this configuration. Look, compare these two configurations. Hydrogen 3 remains in its own place, whereas 1 and 2 are interchanged. Therefore, reflecting about the plane which passes through NH with 3 number designated 3, you will get the configuration. Therefore, the combination of sigma V1 and C3 twice will result in the operation sigma V thrice. Now look at this configuration. Sigma V double dash, C3 twice. What is sigma V double dash? It is reflecting. Who is 18 chemistry 13? Don't do that. You are annotating. Sigma V double dash, C3 twice. What is sigma V double dash? It is reflecting about the plane which passes through NH with number 2. So it passes here. Therefore, the 1 and 3 are interchanged. Now C3 twice. C3 twice means 240 degree rotation. Therefore, the 2 will go to the position 1. 3 will go to position 2. And 1 will go to position 3. Therefore, this is the configuration we are getting. Now you look at this configuration and this configuration and find out one single operation which will result in this conversion. So when you compare this configuration and this configuration, hydrogen 1 remains in its own place, whereas 2 and 3 are interchanged. Therefore, reflection about the plane which passes through N hydrogen 1 will result in this configuration. Therefore, the one single operation corresponding to the combination of sigma V double dash and C3 twice is a sigma V dash. Now look at the third one, sigma V triple dash C3 twice. What is sigma V triple dash? It is the reflection plane which passes through NH, which is designated 3. Therefore, this is the plane. Therefore, H3 remains in its own place. 1 and 2 are interchanged. 1 comes here and 2 goes there. Now the second operation is performed C3 twice. C3 twice means 240-degree rotation. So by 240-degree rotation, 1 goes to the position of 3, 2 goes to the position of 1, 3 goes to the position of 2. Therefore, this is the rotation we are getting. This is the resultant configuration we are getting. If you compare this configuration and this configuration, what is the relation? See, look here, 2 remains in its own place where 1 and 3 are found interchanged. Therefore, any plane which passes through NH with the 2 number, that will result in the configuration what we have got here. Therefore, the combination of sigma V triple dash and C3 twice will result in the one single operation sigma V double dash. Now look at the third operation. So this is, with this we come to the end of the second row. Sorry, the third row. Now look here. When you do this operation, you will understand actually what I have said, not to change the position of the plane. Now let us go back and see. Somebody has drawn this one. Number 18. Who is 18? Number 18, please unmute yourself and speak.
Yes, sir.
You delete this man. You have drawn a line here.
Yes, sir.
Delete.
What, sir?
You have drawn a line here. One black line is there, no?
No, sir.
I don't know how to delete that. Okay, right. Okay. Let me see. Look at this. So the third row we have completed and we are going to the fourth row. Now you will understand what I have really said. Watch closely. C3 once, sigma V once. Watch very closely. If you don't understand this, you cannot complete the multiplication table for any molecule. Look here. This is the original molecule taken. Nitrogen at the center, hydrogen, hydrogen, hydrogen. Numbers are given like this, 1, 2, and 3. First, I am operating C3 once. So when C3 once is operated, I am rotating the molecule for an angle of 120 degree. Therefore, 1 comes here, 2 comes here, 3 comes here. Now I am reflecting about the plane sigma V dash. Watch closely. I have already told you sigma V dash is the plane which passes through NH1. Now after rotation, the H1 has come here. Therefore, you should not change the position of the plane. This is not NH1. NH1 is remaining here. Sigma V dash is remaining here itself. Don't reflect about this plane. That is sigma V double dash. So sigma V single dash is the plane here. Plane does not change when you rotate the molecule. Therefore, you have rotated the molecule for an angle of 120 degree, but H1 has come to this place, but sigma V dash remains in this place. Therefore, NH2 here and 1 and 3 are interchanged. They are reflected. So 1 is reflected over there, 3 is reflected over there. This is the resultant configuration of two operations, C31 and sigma V1. Now we have to find out what is that one single operation which will result in the transformation of this conformation into this conformation. If you look, these two configurations, H3 remains in its own place, whereas 1 and 2 are interchanged. Therefore, any plane which passes through NH, the 3 designated hydrogen, that will result in this configuration. Therefore, it is sigma V triple dash. Therefore, the combination of sigma 3 C31 and sigma V dash will result in sigma V triple dash. Now look here. I take another operation. Sigma C3 twice and then sigma V once. Look here. I rotate the molecule for an angle of 240 degree, and then I'm going to reflect about the plane sigma V dash. Now the sigma V dash is in the same position. Look here. I am reflecting about the H3 now. H3 now. So I am getting this one. I'm getting this one. What is this? So the resultant configuration can be obtained by sigma V double dash. So look here, sigma V dash, E. Now look, sigma V double dash, sigma V dash. What is sigma V double dash? Reflection about the plane this, N, H, given the number 2. So when you reflect the plane about this plane, you are getting the hydrogen with the number 2 remains in its own place. 1 and 3 are interchanged. Now I am reflecting sigma V dash. Sigma V dash, again I repeat, sigma V dash is not here now. Sigma V dash is here. It does not change its place. Therefore, you are reflecting about this plane. Therefore, 3 remain in its own plane. Here 1 and 2 are interchanged. Now you look at the structures, this and this. What is that single operation which will result in this configuration? Look, 1, 2, 3, everything is interchanged. All the positions are changed. Therefore, what operation can be done? Where is 1? 1 is here. In the resultant configuration, 1 is here. Therefore, I have to rotate an angle of 240 degree. Therefore, the combined operation is C3 twice. Therefore, sigma V double dash and sigma V single dash, the combined operation is C3 twice. Look here, sigma V triple dash, sigma V dash. What is sigma V triple dash? Sigma V triple dash is reflection about the plane which passes through NH number 3 here. Therefore, H3 remains in its own place. 1 and 2 are interchanged. Now I am reflecting about sigma V dash. What is sigma V dash? Which passes through NH1 in the original configuration. You are not supposed to change the position. Therefore, this is sigma V dash. Therefore, 2 remains in its own place and 1 and 3 are interchanged. Therefore, what will be the one single operation which will bring this configuration from this? 1 is here, all positions are interchanged, but 1 has moved over here, 2 has moved over there, 3 has moved over here. Therefore, if you perform the operation C3 once, you will get this configuration. Therefore, sigma V triple dash and sigma V dash, the combined operation will be C3 once. Look here, C3 once and sigma V double dash. What is C3 once? Rotating for 120 degree. When you rotate the molecule for 120 degree, 1 will go here, 3 will come here, 2 will go there. That is what is drawn here. Now you reflect about sigma V double dash. What is sigma V double dash? Which passes through the hydrogen number 2. Now the position should not be changed because the hydrogen has changed its position. About the same plane you have to perform. This is the plane, sigma V double dash. So 3 remains in its own place, 1 and 2 are interchanged. So this is the resultant configuration of these two operations. Now you find out what is that single operation which will result in this conversion. So from this conversion, this configuration to this configuration, is there anything remains unchanged? Hydrogen 1 remains unchanged, whereas 2 and 3 are interchanged. Therefore, reflecting about a plane which passes through NH1 will result in this configuration. Therefore, the C3 ones and sigma V double dash operations are combined to form sigma V dash. Now look at this one, C3 twice and sigma V double dash. What is C3 twice? Rotating the molecule for an angle of 240 degree. Therefore, 1, you are rotating and the 1 comes to this place. Look here. You are rotating 2 and 2 comes to this place. Look here. 3 rotates to is changing its position to here. Now we are going to reflect the molecule about sigma V double dash. Sigma V double dash is the plane here. You are not going to change the position of the plane. Therefore, it is here. Therefore, H1 remains in its own place and 2 and 3 are interchanged. Now you find out one single operation which will result in the configurational change. From here to here, hydrogen 3 remains in its own place, whereas 1 and 2 are interchanged. Therefore, any reflection about the plane which passes through NH number 3, that will result in the configuration this one. Therefore, C3 twice and sigma V double dash will combine to result in one single operation, sigma V triple dash. So look at this one, sigma V dash, sigma V double dash. What is sigma V dash? Which passes through NH1 in the original molecule. Therefore, H1 remains in its one place, H3 and 2 are interchanged. And again, over this, sigma V double dash is operated. Sigma V double dash is here. You are not going to change the position of the plane. Therefore, plane is here now. Therefore, H3 remains in its own place and 1 and 2 are interchanged. What will be the one single operation which will result in the conversion of this configuration to this configuration? Look here, all the atoms are changed. Positions are changed. Therefore, it cannot be a reflection plane. But 1 has come over there. It is here. 2 has come over here. Therefore, C3 once rotating the molecule for an angle of 120 degree will result in this configuration. Therefore, the combination of sigma V1 and sigma V double dash will result in the configuration, so in the operation C3 once. Similarly, sigma V double dash and sigma V double dash will result in E because we are reflecting and re-reflecting about the same plane. Now look here, sigma V triple dash and sigma V double dash. Look, where is sigma V triple dash? That plane which passes through NH number 3. Therefore, H3 remains in its one place. Yes, Emmanuel, what is your doubt? You are raising your hand. Jabez?
No, sir. தெரியாம படிச்சேன்.
Okay. Are you able to understand?
Yes, sir. Yes, sir.
Okay. Now, sigma V triple dash is in the NH3. Therefore, 3 remains in its one place. 1 and 2 are interchanged. Now, over this, I am operating sigma V double dash. Where is sigma V double dash? It is here in the NH2 position. In the resultant molecule also, it is here. You should not change the position of the plane as the hydrogen has changed its position. Therefore, it is here. Therefore, H1 remains in its own plane where number 2 and 3 are interchanged. Now you find out one single operation which will result in the conversion of this configuration into this one. Look here, all the hydrogen atoms are changed their positions. Therefore, that single operation which will result will be, see, hydrogen 1 has moved over to the position of 2. 3 has moved over to the position of 3. Therefore, when you rotate the molecule for an angle of 240 degree, you will get this configuration. Therefore, the combination of sigma V triple dash and sigma V double dash will result in that configuration, that operation C3 twice. Therefore, with that, we complete the third row also. Now you look carefully with all these things. And then you ask me any doubt. Anybody is free to ask a doubt. Anybody has any doubt? I think I have given you the unmuting option. You can unmute yourself and ask me any doubt. Anybody has doubt? No doubt. Kanagavalli is there? Certainly you will be having doubt because this idea you have to do with your imagination. If you are not able to imagine the ammonia molecule as you see from above, you cannot perform this. That is why I have changed the configuration to this. Because you cannot do the operations assuming the molecule like this. In a pyramidal shape, you cannot, it is you actually have to do in the pyramidal shape. But for simplicity, you are looking at this like a trigonal planar. Because we do not have any operation to change this. It doesn't have any other thing. Only sigma v's. That is why we have changed the configuration to look at this molecule like this from above. You can look at the molecule in any direction. The beauty of the group theory is this. You are not going to disturb the molecule. You are not